The first part of this video will review the various results that you can expect to get from the wizard. The second part of the video will review the various inputs necessary to achieve those results. First thing to do is press one of the gun buttons. In this case we pressed gun number 1. Then press the answer scroll button, and the first result that comes up is bullet drop. This is the distance below the line of sight that a bullet will drop at a given range. Press the button again and we have point blank range. Point blank range is the furthest distance you can zero your rifle for, at which your bullet is never above or below the line of sight by more than a certain amount. In other words, you can then aim at the center of the target at any distance from the muzzle to the point blank range without the need to adjust elevation. Press the button again. We have sight correction clicks. This is the number of 1/4 minute clicks you must adjust the elevation on your sight when changing from a previously sighted in distance to a new distance. Next, we have velocity at a given distance. Input the distance and the wizard will calculate the bullet's velocity at that distance. Next, we have energy at a given distance. Input the distance and the wizard calculates the bullet's energy at that range. This is important information for hunters who want to ensure that the bullet has enough energy for a humane kill. Next we have the near zero, and by pressing the button again, the far zero. These are two important concepts to understand when sighting in. The path of the bullet crosses the line of sight at 2 points, the near one being the near zero and the far one being the far zero. Typically the near zero is 28 to 32 yards from the muzzle. If you have your sights correctly adjusted for elevation at the near zero, you will automatically be dead on target at the far zero. Understanding this saves a lot of time and ammunition in sighting in. Next, we have the mid-range point. This is the distance from the muzzle where the trajectory of the bullet is highest above the line of sight. Next, we have correction for shooting at an angle. Whether shooting uphill or downhill, as long as the distance is the same or less than the sighted in distance, the correction will always be to shoot lower rather than higher in both cases. The reason for this is that gravity only affects the horizontal component of the bullet's flight. The wizard will use the zero distance, the distance to the target, and the angle to calculate the correct firing solution. Next we have target lead. This is the number of feet you should hold in front of a moving target. Next we have twist rate. This is the optimum twist rate of the barrel necessary to properly stabilize the bullets that you are shooting. Longer bullets require a faster twist rate than shorter ones. Next we have maximum range. This is the maximum distance in yards that a bullet will travel when fired at an angle of from 31 to 33 degrees to the horizon. It has important safety implications, and due to a whole range of variables, should always be multiplied by a factor of 3 when taking into account what may be downrange. Next, we have recoil energy and recoil velocity. These are the two components of recoil. However, due to differences in the build of shooters and other factors, felt recoil may vary considerably from one shooter to another. Next, we have power factor. This is of particular importance to certain types of handgun shooters, especially those shooting in IPSC competition. Next, we have time to target. This is the elapsed time from when the bullet leaves the muzzle till it impacts the target. Next, we have maximum vertical height. This is how high the projectile will travel if fired straight up. Next, we have time ascending. This is the amount of time it takes for the bullet to reach maximum vertical height. Next, we have time falling. This is the amount of time it takes for the bullet to fall from maximum vertical height. Next, we have terminal velocity. This is the maximum speed a bullet will travel when falling from maximum vertical height. Next, we have bullet RPM. This is the rotational speed of the bullet. Now we go to the inputs. Press a gun button, then press the enter button, and the first input will present itself on the display. By continuing to press the enter button, you'll be able to cycle through all of the inputs. First entry is velocity at the muzzle. However, the term muzzle velocity is slightly misleading because in all probability the bullet is still accelerating after it leaves the muzzle. You want to take a reading when the bullet has reached its maximum velocity or the velocity has begun to decay, and this may take place several yards downrange. The next entry is velocity at reference target, and this would be the velocity at another target at a point downrange. The next entry is distance to reference target. This is the distance between the 2 points where you're taking your velocity readings. The next entry is the mid-range height. This would be the maximum distance between the line of sight and the trajectory of the bullet. And this piece of information is important when calculating point-blank range. The next input is sight to bore distance. This is the distance between the axial center line of the scope and the axial center line of the bore. And it is important in all calculations having to do with sight adjustment. The next input is bullet weight in grains. The next one is bullet length in inches. This particular input is important when calculating optimum twist rate. The next input is the bullet diameter in inches. The next one is the powder weight in grains. Powder weight is an important component to the calculations dealing with recoil energy and recoil velocity. Just like the bullet, in one form or another, the mass of the powder exits the muzzle. Next we have gun weight in pounds. Then we have target speed in feet per second. This particular input is important when calculating target lead. Sight zero distance. This is the distance at which the sight has been zeroed. Next, we have range to drop target. This is the distance the wizard will use to calculate bullet drop to a target at a distance other than the zeroed in distance. Next, we have range for angle correction. This is the distance in yards from the muzzle to a target that is either uphill or downhill from the shooter. Next, we have range for sight correction. This is the distance that the wizard will use to calculate the number of quarter-minute clicks necessary to adjust elevation when shooting at a distance other than the zero distance. Next, we have range for velocity. This is the input necessary for calculating velocity at a given distance. Next, we have range for energy. This is the distance that needs to be input for calculating energy at a given distance. Next, we have range for lead. This is the distance that must be input for calculating the number of feet to lead a moving target. Next, we have range for time. This is the distance that needs to be input for calculating the bullet's elapsed time from muzzle to target. Next, we have angle up-down degrees. This must be entered for developing shooting uphill and downhill solutions. Enter the twist rate stamped on the barrel to calculate bullet RPM.